Hey, geometry students. Sorry that I forgot to tell you on Wednesday that I'm going to be out today. I'm in the building doing some curriculum work, and hopefully I'll stop by to answer some questions. But I'm hoping these videos will be able to provide today's lesson so that you'll be able to do the class exercises and the homework. So let's get started. So last class on Wednesday, excuse me with the technology a little bit. I'm sure this is going to be a bit of a learning experience. So on Wednesday, we said that if two triangles are congruent, then the matching parts are congruent. And we called this CPCTC. Corresponding parts of congruent triangles are congruent. Today's lesson, we're going to turn that around and we're going to say if matching parts are congruent, then the triangles are congruent. So the good thing, by the way, about this being a video is if I'm going too fast, you're trying to take notes, you can always pause it, go back. If you don't catch something, you can go back and watch it again. So obviously feel free to do that as we go through. So let's start with this idea of if matching parts are congruent, then the triangles are congruent. So the most obvious way that this can happen is if all the matching parts are congruent. In other words, I'll have two triangles and we have a set of matching sides. Then the next angle is going to match. The next set of sides matches. The next set of angles match. The last set of sides are congruent. And then the last set of angles are congruent. So if we have that situation, then the triangles are clearly congruent because we could take one triangle and put it directly on top of the other because everything about the two triangles is identical, right? And I'm going to call this SA, SA, SA. And that's going to stand for side angle, side angle, side angle. In other words, we have all six parts, all three sets of sides, and all three sets of angles matching up perfectly. And that's going to make the triangles are congruent. But that ends up being a lot of work because we have to show six different pairs of congruent parts. It turns out there's some shortcuts that we can use instead of needing to show that all six parts. And so the shortcuts are going to be with three sets of parts. So the first thing I'm going to do is we're going to list all the possible sets of three parts that could be congruent. And then some of them are not going to be able to show us that triangles are congruent, and some are. So let's list the possible sets of three parts that we can have congruent. So the first one that we're going to list is side, side, side. So that's the three sides of one triangle are congruent to the three sides of another triangle. The next one that we're going to list is side angle side. And that is you have two sets of sides and the angle between the two sides. And then I'm going to do side, side angle. And for that one, we also have two sets of sides, but the angles that we're matching up are not the angle between the two sides. It's an angle outside of them. So side angle side, you would have a situation like this. You have two sides and the angle between them. So I'll draw the second triangle too. You have two sets of sides and the angle between them. And then side, side angle is you're going to have the two sets of sides, but the angle that you have matching is an angle that's not included between those two sides. So even though both of those have two sets of sides and an angle, it's important where that angle is, and those are considered two separate cases. By the way, you might notice that side angle, I purposely spelled it backwards because it is a not so nice word, but that's actually going to help us later to remember something about that case that it ends up not working. So the fact that it's a bad word helps us to know that we actually can't use it to prove triangles are congruent. So our last three sets of three parts are, we could have angle, side, angle. So two sets of angles and the side between the two angles. We could have angle, angle, side, where we have two sets of angles and then a matching pair of sides, but the sides are not between the angle. And our final one is angle, angle, angle. So those are the 6 different possibilities of 3 parts that we could have in a triangle. And now we're going to look at which of those is going to be able to show us that the 2 triangles must be congruent. Okay, so the first one we've actually already done before. So this top one here was what we did on our first GeoGebra activity on page 25. I gave you 3 side lengths, and it turns out when you use those 3 side lengths, it only made one triangle. So no matter how you moved any of the GeoGebra construction points around, it always stayed exactly congruent to itself. So having 3 sets of sides in one triangle, the same as 3 sets of sides in another triangle, is enough to prove that the 2 triangles are congruent. Let's skip to the bottom one, the angle, angle, angle. So last class, actually, you guys mentioned, and we saw that it was possible to have the same 3 angles. So let's do a triangle. Let's say it was, I think we did 30 degrees, 60 degrees, and 90 degrees. And you could have another triangle with those same angles. So you have a pair of 90s, that's one pair of matching angles, a pair of 30-degree angles, and a pair of 60-degree angles. And those triangles are not congruent because they're different sizes. So just because you have 3 sets of congruent angles is not enough to show the triangles are congruent. So that one doesn't work. And then we have 4 left, and we're going to talk more later about sort of proving why these work. The book actually calls them postulates for now, and a postulate is something that we believe is true, but we have not yet proved it's true, compared to a theorem, which is something that we've proven is true. So the perpendicular bisector theorem is something that the book actually did with folding that was proven to be true. We did it with GeoGebra. And saw that wherever we moved the point, it was all equidistant, always equidistant from the endpoints. So of the last 4 of these, it turns out that the only one that doesn't prove congruence is that one that is the bad word backwards. So it turns out that the other 3 all work. So these are the 4 different shortcuts that we can use to prove that triangles are congruent. And I'm now going to have you copy down some notes to write these out.